Hi, my name is Brad Goff. When I'm not on the U.S. Olympic diving team, I'm a corporate SE here at Nutanix. Today, we'd like to take a minute to talk about snapshots and replication with you.
Need a little excitement? Snap into it!
Nope, not those types of snaps and replication, this type of snaps and replication. I'm going to start off with snapshots first. What I have here is a diagram that Stephen Portress actually did on the Nutanix Bible. We're going to add a link there, but I would suggest that you guys watch that either before or right after watching this. I'm not going to completely go over everything that he went over in this, but this is going to relate heavily with it. So in a nutshell, this is how we do snapshotting. So we're going to start here. This is our original snapshot, or our base vdisk. Every snapshot that we have is going to create an independent vdisk. As you can see underneath, these are blocks that we have. I've color-coded them so you can see which color goes to which block. This is snapshot 1, this will be snapshot 2, and this will be snapshot 3. Our snapshots and our clone methodology are very similar / the same. But going into this, as we can see, this is our base vdisk. This is where we started, and these are the blocks that base vdisk owns. Whenever we create a snapshot, we're going to make this read-only. We're going to come over here, we're going to create that new snapshot. Our new read-write requests are going to go into this new snapshot. All the change blocks are going to go here, but we're still going to reference this other block mapping over here. And we're going to rinse and repeat that as we go forward. So going into that, there's two common types of snapshot methodologies. You have redirect on write or copy on write. For us here at Nutanix, we chose redirect on write. For the main differences between those, so we don't get super granular in this video, I would say Google those. But just so that you know, redirect on write, the benefits that we achieve from that are 1/3 of the I/O, and there is 0 to minimal CPU overhead whenever you use redirect on write. So you're probably thinking, why did I do all of this? Well, I need to kind of teach you to crawl before you can walk. So let's take this and put this into a real world scenario, why this is better. So let's say that you have a customer that takes hourly snapshots from 12 to 5, okay? These are gonna be hourlies. So your hourly snapshots, so we're gonna come down here. So we have hourly snapshots, okay? So let's say that we need to do a restore, right? The Nutanix way to do a restore is, let's say that the customer needed to go to 2 o'clock, okay? That's fine, we can do that, independent vdisks. Anybody can do that. The cool thing about us though, is that if they did the restore to 2 and it turns out, oops, that wasn't the right restore that I needed to restore to 3 instead, the way that we do independent vdisks, the customer is able to do that. So from 2 o'clock to 3 o'clock is no problem. After they restore to 3, they can go to 4 or they can go to 5, which is really cool because traditionally, if you're doing snaps, since they're going to be volume snaps, you're looking at overriding all of this. So if you're here now, and then you went and restored to 2, you can't restore to 3, 4, 5. You lose that forward track because of the traversing the snapshot chain and the way that works. So really cool with the way that we do independent vdisks. This is a really, really nice real world scenario that you can talk to customers about. This is also a pain point that customers really can feel. If they've ever been hit by like ransomware or something like that, this is going to say, hey, listen, if that does happen, we can restore back. And then if it's not where you need to be, you can go forward to where you actually need to be within your data. So cool stuff. This time we're going to go over replication. As you can see, I've already pre-whiteboarded it a little bit here. On this side, I have Nutanix, which is us. SAN, traditional SAN topology, which is them. So us versus them. What I want to go over again is replication and how we do replication and how we differ in our replication schema. So when we talk about traditional SAN replication, right, you're talking about trying to retrofit some stuff. So SAN NAS technologies were developed way before virtualization was even thought of. So with that being said, they kind of had to retrofit virtualization into that SAN method. So as you can see here, we've got VMs. VMs live inside of data stores, and data stores live inside of volumes on the SAN side, okay? To this, it's not a problem. This is, whenever you create a snapshot, you will create a volume-based snapshot, okay? It's fast, simple, easy on the source. The issue with this is whenever it comes into replication, all right? So let's say that my VMs live in this data store lives in this volume. I want 5 of these VMs, but I have 15 VMs in that data store, but I need to back up 5 of them. I take a snapshot, again, fast, on the source. However, when I replicate, we have to replicate that volume, and it has to be a like-for-like replication. So this side has to be exactly what this size is. So if I have 5 VMs that I want to back up, I have to actually take that whole data store, that whole volume, and replicate it. So if this is 2 terabytes, I replicate 2 terabytes over, right? Very, very, very inefficient. Again, fast here, slow over the pipe because you have to replicate all of that, not just the few VMs that you wanted. So switch it over here, Nutanix. Alrighty, so we understand how SAN works, we understand how virtualization works. Essentially, that's 2/3 of what we do with our whole hyper-convergence. So with us knowing that, we came through and we made this a lot more efficient. So our VMs live inside of the containers, right? So we have those containers that we create. But when we do replication, we create protection domains. Our protection domains are completely VM-centric. So my VMs, I can back them up. So let's say that all of my SQL VMs, I can create a protection domain called SQL. I can pull 5 or 6 of those VMs out of that storage container into this protection domain and then replicate just those VMs. Super efficient, right? Because you're only replicating exactly what you need, how you need it. Another cool thing that differs between the two is these are not like for like. Again, this side, if you've got dedupe, compression, whatever size it is, you have to have like for like on the destination. On this side, we can have dedupe compression enabled on the source and not enabled on the destination container. It doesn't matter for us. So again, just another cool feature that we have. So that's essentially how we do replication versus how traditional replication is done, and a really, really, really good focusing piece whenever you have to explain that. Again, from an SE perspective, when you go into explaining replication, make sure to say that the virtualization was kind of retrofitted to SAN for replication, right? But that is part of what we do. We've thought about that, we've made it more efficient, and this is how we do it. Again, for replication points, we can replicate to either another Nutanix cluster or to the cloud using AWS or Azure. We can do this all the way there. This again, natively, you're going to have issues doing that. So again, Brad Goff, Corporate SE here at Nutanix. Thanks for watching the video.